Hello everyone, this is Hakeem Wilson. This is the video for Lab 7 through 8. I am partnered with Elijah Billings and Mark Fittler, and I'm going to go over our setup for the mass flow sensor. So we have a little cardboard tube here that ends on the inside. There is a 50 ohm resistor that is connected to a 12 volt battery. The two temperature sensors are both connected to my BugleBone Black. And then we also have a Arduino Uno that is being used to control the electric speed controller for our 4500 kV brushless motor. The 4500 kV means that this motor will spin at 4500 RPM for every volt applied. In our case, I've limited it so that we are applying 10 volts to the motor. So when I turn the potentiometer at full throttle, the fan will spin at 45,000 RPM. Our resistor heating source is also connected to that 10 volt power supply. So with that, we are dissipating about 2 watts of heat through the resistor. Then for our calculation of our K factor, we determined that, well, using the formula K equals rho times V times A, we know that rho is air density, which is 1.225 kilograms per meter cubed. Air velocity that we calculated from our fan blade spinning at full throttle is 98.2 meters per second, which is probably going to be a lot higher than what most people were getting. And that our cross-sectional area of the tube was 0.0008 meters squared. Sorry. And this all led to us having a K value of 0.096236. And with that, I'm just going to jump into the software that we use. The software we used were the default analyzer and server code that Professor Fallon had provided to us. Alright, and from there we'll just jump into the demonstration. Alright guys, so we've got the server application running as well as the GUI analyzer, and I've let it level out first. So right now we're looking at values somewhere in the neighborhood of 0.04. That's an idle. So I've got everything hooked up to a battery. The temperature sensor, you can see the first one's inside that tube right there. This is the fan we're going to be using. Now, this experiment isn't perfect. Ideally, in the future, I would want to have this housed inside of a tube large enough so that we could trap all the airflow that's being pulled in through the fan blades directly through the tube. But because of limited resources, and you have to do it this way. So it's not perfect, but it should be good enough to get some decent values. Alright, so I'm going to be careful. I'm going to hold this real tight. Hold it parallel to the tube. And let's turn this potentiometer and I'll turn it on. Alright. Alright, yeah, so we were peaking some pretty high values. Looks like the analyzer program crashed. After this part, the numbers usually starts settling back down towards the 0.04 that we saw when we started. So all in all, I think this experiment was a success, but like I said, there are a few things I would go back and change if I had more time and a few more resources to do this. All right.